Hi, I would like to dedicate this video to a molecule that's very interesting, and the humanity has had to deal with this molecule for a long time, and that's carbon dioxide or CO2. And currently there's a lot of worries for climate change, and I'm not going to take any sides in this. I already have people up on my neck in arguments over issues that are very controversial. But I want to just show some mitigating circumstances and some solutions for carbon dioxide sequestration, and also its application in terraforming other planets, because naturally most of the rocky planets, they have a lot of CO2 in their atmosphere, and our planet must have had a lot of CO2 at some point in its early history, but we don't see any of it because the cyanobacteria and the plants, they use the carbon as a resource. To them it's like food, and they use the carbon and the free energy from the sun to construct carbon chains, and then make all kinds of other molecules, or make their own bodies. We don't look at things in this fashion. We don't look at carbon dioxide as a resource and as food, because we are human. We don't think like that, like bacteria. But I would like to point out that there are a lot of molecules in the air that are just like a resource. They're very valuable, and if we deplete them, we will face another ice age. Well, people say, okay, the Earth's temperature is rising, but our planet is mostly water. 70% is water. It's covered with water, basically. And if the temperature rises, then that automatically means there will be more moisture in the air, then more precipitation, and what happens after a lot of precipitation is that a lot of new plant life grows on the land, and the plant, once the plants start, they don't just die out within a year or two or three. A lot of plants, they last longer. They last maybe 2, 3, 5 years, 10 years. Trees last a long time. And if there is a lot of precipitation, then the temperature has risen, and there's more land available near poles for plants to grow, well, they'll grow. And you don't know how much mass of cells and tree branches and growth that would happen in 1 acre. It could be a lot. I mean, I don't have the numbers on me, but what happens, I think, is this is like a feedback loop, where once the plants start growing, they absorb a lot of the carbon dioxide from the atmosphere, and this lowers the greenhouse effect of carbon dioxide, and then it starts or onsets the age of the ice age. That's how we have been going through ice ages, is because the plants, they absorb too much carbon dioxide. And we could also start ice age by different mechanisms. I think the climate change will be more going toward ice age, and we should be more mindful of how much carbon dioxide is in the atmosphere and how much do we want to take out. Well, uh, because of our long history, we're used to thinking that well, nature has to take care of us and but we are too sophisticated technologically, and we can do things that nature never dreamed of. Well, for example, I'll show you a way to take out only certain portion of the carbon dioxide, not all of it, by using cyanobacteria that are genetically modified. For example, we could genetically modify cyanobacteria to only grow in a certain culture with a certain pH or alkalinity, and grow them in shallow pools, or make them grow very fast, and this way absorb the carbon dioxide naturally. By modifying these organisms, we want to make sure that they don't grow everywhere. They don't grow in fresh water, or they don't grow in the seawater. They're contained to our own environment that we prescribe. And this is not really a wish. This is more like the technology is right there. And I'm myself diabetic. I use insulin that was made by bacteria. So there is a lot that the bacteria can be programmed to do. We can take genes from many different bacteria and instruct them to grow faster, to make alcohol, make diesel fuel, make absorb all the carbon dioxide, make long chains that they can never go back into nature. They're locked in a molecular matrix. You name it. If we manage to do this right, and we have say we have a cyanobacteria that grows in shallow pools and grows abundantly, quickly, in only a certain salt that we add to this water, that this is the reason we want them to grow only in this kind of environment. Okay, so say they grow up and the whole pool is full of cyanobacteria, is millions of them per cc. Okay, so figuring out how much carbon has been sequestered through these organisms, it would be just like a linear relationship. Okay, so much water, so much of this salt, so much of this bacteria, and so much of this carbon. I mean, it becomes almost like a public service. The government constructs these shallow pools, pours in the salt, and removes the cyanobacteria. Once they grow, the removal is quite easy, because they're in a liquid form, and they could be used as irrigation water, and all their bodies will die and become fertilizer. Or they could spray onto sand dunes, or sand reclamation projects, stuff like that. I mean, it will be a cinch. You invest $1 billion, and you know how much carbon you got out of the atmosphere. It's like almost a linear relationship. So if I want to do public service, I'll invest 10 billion. I will have 10 times as much of the carbon. You could also relate it to the number of cars, the exhaust from number of cars, or the average exhaust from the cars. The beautiful thing about using cyanobacteria is that you could insert so many genes and make them do. You could use genes from thermophiles, from extreme organisms, to do very funky things. One idea that I have, and I think this is an original idea, if somebody wants to use it later on, please remember me, is Some earlier spacecrafts to the planet Venus had discovered that the temperatures around the outer atmosphere of this planet is not as hostile as we go in. So also it's pretty evident that there is bacteria on all of Earth's atmosphere. Some are floating miles high. What I propose to do is modify the cyanobacteria, and this has to be done very thoughtfully because it can go really out of hand. But to modify it in a way that it will float because it's lighter than the atmosphere of Venus, and also it would absorb carbon dioxide and sulfur compounds like SO2, SO3, S2O3, and so on, and make long chains and basically remove these noxious items and just give up oxygen. Okay, the thing that makes me hopeful of this project working out, but there has to be it has to be done really thoughtfully, is the fact that if you have a petri dish and the conditions are right, you drop in a few bacteria. After a little while, all the food and all the compounds that could be consumed in that petri dish, they all become the bacteria. They multiply very quickly. Well, if we construct the cyanobacteria that would think of carbon dioxide and sulfur compounds as food, and would use the energy of the sun or the heat that's in Venus, and basically remove these noxious gases out of the atmosphere, it can really cascade and they can grow logarithmically, like within a short time the whole atmosphere would be engulfed. I mean, this sounds very incredible, but it's not. There is some references to it in sci-fi. There was an episode in Men in Black where the extraterrestrial comes in and just spurts something into Earth or the atmosphere, and the whole place is just totally engulfed. But we don't need to depend on nature. Our technology is there. It's just we are not used to thinking in those directions. If we left to nature, Venus will sit there another 2-3 billion years before something else happens. But we can do things differently, and humanity should be a progenitor for life and try to do terraforming. And this form of terraforming is very cheap way of doing it, and it just can run amok on its own. But before we do it, you just have to think it out really thoughtfully and design the designer bacteria to do this. The same kind of bacteria can be used in Mars, because a lot of carbon dioxide is in the atmosphere of Mars too. Yeah, these technologies are so beautiful. I mean, I can imagine us doing so many things with them. These projects. The other idea that I had is there is technologies that are synthetic photosynthesis, which means that we have solar cells, and we can use their energy to sucking the air into a container and heat it up or break it down and construct alcohol out of it. It's just a chemical pathway, and it will go if you supply it with energy. And you have to. It's a process. You go through a process. If you have solar cells, it will be possible to use that energy to do this. Well, when I was in New Hampshire, when I was studying there were farmers or people, they use the sap of the tree and make some kind of syrup out of it. And this could be something very similar. You have a few solar cells and a stake, and well, you got after a day or two, you get what, a gallon of alcohol. You can drink it, or you can throw it in the gas tank. I mean, we should think of the water and the carbon dioxide that's in the atmosphere as a free or cheap resource that can be converted to what we want. And if these ideas, they catch on, we can remove a lot of carbon dioxide out of the atmosphere. Another mitigating condition or situation is that because of the internet, a lot of things that required in-person presentation or moving, and you had to do it by traveling, is almost unnecessary. You just send it through text or video conferencing, and bingo, you got it. I mean, that's why oil use is I think is going to drop. The other mitigating condition or circumstance is, in many countries, the population is getting older. Everybody is over 50 in many developing countries, except some African nations. But even in Africa, when people become a little bit wealthier or they have resources, they don't want to raise all these kids. The kids are hard to raise, and they cost a lot of money, especially in developed countries. And I think that the world population is going to stabilize or even drop, because the technology makes people's lives a lot easier. And why would you want to spend all your time attending to kids when you can do a lot of other things? That's the extent of my mitigating conditions. And there are other technologies for sequestering CO2, like pumping it into abandoned mines, or there are chemical compounds that absorb it. But I think the bacterial solution, the cyanobacteria, is the very best, because the complete end product is some kind of liquid. You can just spray it on the farm or anywhere. I mean, that is fertilizer. That's cheap fertilizer. I mean, I would do it as a public service if I was the government. Even if the carbon dioxide is sequestered into mines or shafts or whatever, it can be recycled later on when our technologies evolve better and we could dig it out, because carbon by itself is valuable. Say you have a lot of carbon dioxide and you have a real cheap energy to break it down into carbon and oxygen. Well, you can use the carbon again to burn it again, or industrial use. I find this subject fascinating, and it should find applications in terraforming. But if we design the right cyanobacteria, it could make, for example, within a 10-year period, drop the temperature of Venus hundreds of degrees. I mean, it would be incredible. Anyhow, I will go over some other very crazy ideas in next video. Okay. See.